All right, so vectors, which is something that is new to us, okay, unless you're in physics, you may have heard about vectors, but it's new to, like we didn't do this last year. So vectors are something, it's almost like an array with a direction and slope, okay? So they look like this. This is a vector. It's similar to array in that it has an arrow for direction, but what's different about it is it ends. So if you remember array from geometry, it's unending, right? The arrow's at the end, which means it continues on in that forever in that direction. A vector is different in that it does have endpoints. So notice that there's an initial point and a terminal point, okay? Which means it can be measured. We can actually measure the length of a vector. A vector has two types of measurement. One is the length, which is called magnitude. We'll also talk about that in a second. And the other is direction, and that is almost like its slope. It's its change in x and change in y. There's a couple different ways, well, two really, different ways to name a vector. You can either name it by the coordinate points letters, like this, ray or vector PQ, where the arrow will be in the direction of my terminal point. So the order of how you name a vector is important. That little half arrow goes over the terminal point. You can also call it by a single bolded lowercase letter. Sometimes it's italicized, but usually it's bolded. So I could either call this vector PQ or I could call this vector V. And again, the order of the PQ matters because it's initial point to terminal point. The first thing we're going to talk about is the component form of a vector, and the component form is its change in x, comma, change in y. So it's almost like slope, except we write it as a coordinate point, or it looks like a coordinate point, okay? There's a couple different things that you got to pay attention to here. One is these are not parentheses. Those little brackets tell you this is not a coordinate point. This is a component form of a vector. So if I saw something like 2, -3, that is not a point. That is a change in x and a change in y. You'll see a little like triangle that represents change. It could also be written like that. So change in x and change in y. To find the component form, you'll get given two coordinate points, the initial and the terminal, and it's important to know which one's which, because the signs matter here. We would do the second x minus the first x and the second y minus the first y. And then you will keep it in those little brackets. The second unit of measurement that we're going to need to know for a vector is the magnitude. This is the same thing as the length of your vector. And we find it, again, you have two options. One, if you're given the two coordinate points, so let me use the same. P was x1, comma y1, and Q is x2, comma y2. If those are your initial and terminal, then I would do the square root of the second x minus the first x squared plus the second y minus the first y squared. So you're using the distance formula here. If you already have the component form of a vector, like I already know this is 2, -3, then I can jump right in to the magnitude by doing the square root of the first one plus the square root of the second one. So if I have the 2 points, I'm using the distance formula. If I have my component form or my change in x and change in y, then I do square root of a squared plus b squared. And this little v actually should have double lines. A double line around your v is saying magnitude. That is the magnitude of vector v. So double lines mean magnitude, meaning length. And the brackets, like the little sharp brackets, mean component form. Good so far. So two formulas you gotta know. Component form and magnitude. All right, equivalent vectors are vectors that have the same magnitude and direction. So they have the same length and they have the same slope. They don't have to be the same vector. I'm not talking the exact same vector. But they have to have the same length and same direction or slope. All right, example 1 says, show that u equals v. And I know this should be a dot at the end here, and there should be a dot at the end there. This is really hard to do in PowerPoint, okay? They do stop, so it's important to have those. So in order to show that u and v are equivalent, they have to have the same component form, and they have to have the same distance. So the first thing I'm going to do is find the component form of each. So component form of u. What point is my terminal point for u? 2, 3. How do I know that that's the terminal point? That's where it ends. So my terminal point is 2, 3. And my initial is 0, 0. So if I want to do the component form, oh, this should have been a bracket. It's x2, which is 2, minus x1, which is 0, comma, y2, which is 3, minus y1, which is 0. And the component form of u is 2, 3. Now I'm going to do the same thing with v. I'm going to find the component form of v. What's my terminal point? Good. And what's my initial point? Good. So if I want to do the second x, or the terminal x, it's negative 2 minus a negative 4, comma, negative 1 minus a negative 4. My minus negatives become plus, and I end up with negative 2 plus 4, which is 2, and negative 1 plus 4, which is 3. So component form of u, component form of v, and they are the same. So that's the first. God bless you. The first check is, do they have the same component form? Now we're going to practice the magnitude, but if they have the same component form, they're going to have the same magnitude. Not necessarily the other way around. You can have two vectors with the same magnitude, but different component form. If you think about their signs, right? Like if I did negative 2 and negative 3, I square both and add them, I get the same answer as if I did positive 2 and positive 3. So if they have the same component form, they will have the same magnitude, but it doesn't have to happen the other way around. So let's just practice because we're going to have to find it anyways. Magnitude of u, I use the distance formula, or I can do a squared plus b squared from what I just found. So distance formula would be 2 minus 0 squared plus 3 minus 0 squared. Square root of 2 squared plus 3 squared. Square root of 4 plus 9, which is square root 13. And that's the magnitude of u, square root 13. I could have also done square root of 2 squared plus 3 squared based on my component form. Either way, I still get square root 13. Then I do magnitude of v. So again, I can do distance formula. Second x, so negative 2 minus a negative 4 squared plus negative 1 minus a negative 4 squared. The minus negatives become positives. I'd get 2 squared plus 3 squared, 4 plus 9, which is 13. So now we're comparing both magnitudes and component forms. They are both the same. So we would say that these two are equivalent. Questions so far? All right, example 2 says find the component form and the magnitude of vector v. So A and B are two separate questions. I'll do A with you, but then you're going to do B. So the first thing I'm going to do is find component form. And that is x2, 15, minus the negative 1, x1, comma, 12 minus 5, y2 minus y1. This becomes plus, and I end up with 16, comma, 7. God bless you. That is the component form of that vector. Now I want to do magnitude. All right, so now I can either do distance formula. I can do 15 minus a negative 1 squared plus 12 minus 5 squared. Or once I already have the component form, I can just come over here and say square root of a squared plus b squared. So that's 256 plus 49, or square root of 305. And then these are radicals. We're going to keep them exact, but if we can simplify them, we're going to simplify them. So 5 goes in here 61 times, and it can't break down any further, which means I'm going to actually leave it as 305, square root of 305. So component form is 16.7, magnitude is root 305. Not for this stuff. So on your test, there's going to be 2 parts. This, you won't have one. All right, do B. All right, so you should have gotten 8, 6 for your component form, and then 10 for your magnitude. If you think about these, like if I actually plotted something that had the change of 8, 6, I'd be going to the right 8, I'd be going up 6. Here's my vector. I can actually make a triangle from this sucker, right? This would be 8 and 6, and then the part that my vector is my radius, and that is a triple. So these should work like that. Like if I had 3, 4 for my change in x and my change in y, what's going to be my magnitude? 5, right? Like all of your triples will work that way too, because you can form a right triangle from these lengths, okay? Questions so far? All right, now we're talking about a scalar multiple, and a scalar multiple is just changing the length of your vector or changing the magnitude of your vector. A scalar multiple is a number. It could be a fraction, it could be a decimal, it could be a negative, it could be positive, but it is a single individual number. So if I say 2v, I'm saying take the length of v and double it. Keep it in the same direction, which means same slope, but double its length. So that's what all the stuff on the bottom is. If I actually measured v here with like a ruler, and then I wanted to know 2v, I would double its length. On notability, it's easy to do these because we can draw this segment. You could literally like circle it and duplicate it, and you would know how long it is. Obviously, if you're doing this on a test, you don't have notability in front of you. So you also have to understand that you would be kind of, and it doesn't have to be perfect, but you'd be kind of eyeballing something that is double its length, okay? And if it was half, now you're cutting that length in half. If it's negative 3 halves, the 3 half part is 1.5, so that's the length. We've done 1.5 the length. But notice what happened to my arrow. What happened when I did negative 3 halves? The arrow changes direction. So instead of pointing up, the negative changes it to go in the other direction. Obviously, super important. It changes the direction of your vector, okay? So if you're multiplying by a negative, whatever direction you were going in the beginning, you change and you go the opposite direction, okay? Ignore the length and the negative are 2 completely different impacts. The length just doubles it, or in that case, 1.5 it, whereas the negative changed the actual direction of your vector. All right, so these are all the things that we can do with vectors, okay? This is just our initial one. So if my initial vector u is u1, u2, and my initial vector v is v1, v2, and k is a scalar, meaning k is a real number, then I can either add 2 vectors together, and when we add 2 vectors together, we literally add the 2 first terms. So we add the change in x and change in x, comma, add the change in y and change in y. So you keep that separate as a component. If you subtract, then you're doing the first minus the first and the second minus the second. If you're doing a scalar, so like this would be like a 2u, for example, then I would take 2 and I multiply it times both the change in x and the change in y. So you're distributing that in. And then the negative on the front is the same thing as saying -1 times a vector. So you can go in either direction there. If I have a negative on both coordinate points or both change in x and change in y, I can actually take it out and it would change its sign, just like you would if it was you were multiplying by -1 and then you factored the -1 back out. All right, so now let's do some of this stuff, okay? We're going to sketch a vector, and then we're going to talk about what happens when we add them visually. So if I'm going to draw a vector, then again, the first term is your change in x, and the second term is your change in y. If you are drawing a vector and you have initial and terminal, then you plot your initial, you plot your terminal, you draw your vector. But if you only have the component form of it, so let's just say I had 2, -3, and that's the component form of my vector, I don't have initial and terminal, then we start with our initial at 0, 0. So we would start as though it was starting from the origin. And then you plot your change in x and change in y. So over 2, up 1, or no, up, down, negative, down 3. And then you connect them and you point your arrow towards where you just finished. So again, if I had initial and terminal, I would plot initial and terminal and just draw my arrow towards the terminal. If you don't have initial and you only have component form, you're starting at 0, 0. And you're ending at the coordinate point that is your component form. All right, example 2 says find A, actually this should be example 3. A, u plus v, B, u minus v, C, 2u minus 3v, and then sketch each resultant vector. So we're going to find the sums first, and then we'll go back and sketch. If I wanted to find A, u plus v, then I add both change in x's, so I add the first two. This would be 2 plus 1, comma, add the second ones, 1 plus 3. And I get 3, 4. B says subtract them. U minus V. Obviously, order is important here because it's subtraction. So I do U minus V. I would do 2 minus 1 and 1 minus 3. And I get 1 negative 2. And C is 2u minus 3v. So I'm going to take 2 and multiply it in on u. And that is 4, 2. That looks like a 4. And then I'm going to take 3 and I'm going to multiply it in on v. And you can either take positive 3 and then subtract them, or you can distribute in a negative 3 and then add them. It doesn't matter which way you do that. But if I do positive 3, this is still minus. And distribute here, I'd get 3, 9. And now I subtract. So 4 minus 3 is 1. 2 minus 9 is negative 7. Questions so far? All right, I'm going to pull in a coordinate grid just so that we can graph these a little bit more accurately. And for each of these, we don't have an initial and a terminal. We just have the component form. So I'm graphing starting at 0, 0. So for A, I want to graph 3, 4. I'm going to start at 0, 0. I go to the right 3. I go up 4, and I draw my vector. So this is A. B is 1, negative 2. So I'm starting at 0, 0. I go to the right one, I go down 2. That's B. And C is 1, negative 7. So I start at 0, 0. I go to the right one and I go down 7. And that's C. Now you will see like the questions on this, I think on WebAssign are multiple choice. Obviously that's not how it would be on your test. So you need to make sure that you are drawing these by hand and then selecting your multiple choice. Don't just look at those multiple choice ones. Camilla, you had a question?
No, I was just saying, the first numbers.
Change in X. Yep. Change in X, then change in Y. All right, now we're going to use the figure to draw. So now we don't have coordinate points. So this is where we're going to either take our length and we're going to multiply it times 4 and then I'll show you what to do when you get to addition. We're going to do A and C first, okay? And then we'll go back to doing B and D. So if you look at A, it says 4U. So that means I want to take U and I want to multiply its length by 4. I want 4 of those in the same direction. So that's 1. We're going to say that's like 2, 3, 4. This would be 4U. It goes in the same direction. Its length is just quadrupled. Questions? All right, C, I said I'm going to do C, and then we'll go back to the other ones. C is negative 3V. What's the negative do? Change its direction. So instead of going in this direction, we're actually going away from V, but we want 3 times the length. So this is 1V. It goes the other direction. This would be 2-ish V. Now we're at 3V. So this would be negative 3V. This was letter C. So we don't include the initial part of V. We immediately go the other direction if it's negative. Still with me? All right, this is where it gets weird. So if you're gaming, maybe you want to stop for a moment, give your thumbs a break so you can learn something. If I go to B and it says U plus V, the way I find, and it's a resultant vector is what it is at the end. Okay, the resultant vector of a sum of 2 drawn, because I don't know the measurements, I don't have the coordinate points, of 2 drawn vectors, then I actually take those 2 vectors, so I'm going to look at original V, and I draw a parallelogram from their endpoints. So I go from both endpoints, I'm going to do this for both, and I go in the direction of the other vector. So I'm coming off of U, but I want to draw a segment that is parallel to V. So I kind of do something like this. I want to draw, again, a segment that is parallel to the other vector. I come out of the end, the terminal point of one vector, and I draw a segment that is parallel to the other one. Then I'm going to repeat that process for the other one. I go to V, I get to a terminal point on V, and I draw a vector that is parallel, a segment that is parallel to U. And then where these cross is the terminal point of your sum vector. I come out from my initial spot where they both started, and that would be a U plus V. So again, these things, I think this is when it's like easier to do on Notability because you can draw your straight line out from each direction, okay? Realize that when you go to take a test on this, you're not doing it in Notability, so you're going to have to hand draw that. This is, what was that, B? Yeah. Thank you. Yeah.
So the purple one is the resultant.
So the purple is the resultant vector, U plus V. Okay. Yep. I'm going to erase all this, so I don't know if you want to screenshot if you want to like erase and screen. I don't want you to lose all your work because mine saves because I'm on a video, but I'm going to erase all that because what we're about to do next is different. So again, I don't know if you want to copy paste. But when I go to D, you're doing two things this time, right? You're doing a scalar. Well, you're doing three things really. You're doing a scalar because you're going to make U 3 times its length. You're going to make V 2 times its length. But that negative on V is going to do what? It flips it. So this is the same as saying 3U plus a negative 2V. So we treat the negative on the V and change its direction. And then we're going to come out from the ends and find that little parallelogram shape. So first thing I'm going to do is 3U. I'm going to take U, that's 1U, that's 2U, that's 3U. So we're going to say this is 3U. Now I'm going to do negative 2V. So I go the other direction of V, and I want to double its length. So this would be a negative 2V. And now I draw my little parallelogram out of the ends. So I'm going to come out of 3U, go parallel to V. I'm going to come out of V, go parallel to U. Where they cross is the end point of my resultant vector. So this is 3U minus 2V. Questions? Okay, so now everything we just did in that component form, we're just going to rewrite in a different form, and that form is IJ. This time, instead of saying, this is A, B, it would be AI plus BJ. So whatever, let's say that's 2, 3, that becomes 2I plus 3J. It's just a different way of writing it. It means the exact same thing. Whatever's in front of the I is your change in X. Whatever's in front of the J is your change in Y. So A is the horizontal component because it's your change in X. And B is the vertical component because it's your change in Y. Everything else is the same. And if the IJ format throws you, then you literally could rewrite your IJ format in component form and then do everything we just did, okay? So it's just a different way to write it. And if the question is given to you in that IJ format and then it says find the 2U plus 3B or whatever, 2U plus 3V, something like that, you have to make sure that you put it back into IJ format as your answer. And I put it in the instructions on the assignment for tomorrow, but WebAssigns IJ is not your keyboard IJ. So when you go to type it in, you'll pull up that little like special character box, and there's an IJ there. So if you put your regular IJ, it's going to mark it wrong. You're not going to freak out because you're going to have your work. But also, if you want to get it right, you have to use the WebAssign IJ. It says it in the directions on the assignment for tomorrow, but hopefully you'll remember this conversation. All right, so now it says find A, U plus V, B, U minus V, and C, 2U minus 3V. Notice the same set of instructions. And then sketch the result. The only difference is the format it's given to you. So I'll do A by taking it out of IJ form, but then we're going to go back and do it the other way. So if U is 3I plus, that's a J. What is the component form of U? What's the change in X? 3. What's the change in Y?
2.
What's in front of J? 1. So these are the same thing. They're just written in two different formats. So if the IJ throws you, take it out. What would be the component form of V? This is a J. What's in front of the I? 0. So 0, 2. Does that make sense? Yes. So now if I want to find A, U plus V, I add the 2, change in x's, 3 plus 0, and 1 plus 2. And I get 3, 3. So then B, I can either do the same thing, use the component form, and I'm subtracting U minus V. But the other thing you can do with these is treat them as though they are variables. So if I wanted to do U minus V, it would be 3I plus J minus 2J. And then I can just combine my like terms. It would be 3I minus J. Because this is not in IJ format, right? I actually have to put that back in IJ format for my answer. Whereas if I treat them as though they're variables for B, I don't have to put it back. That is my answer. So these are my answers here. C says 2U minus 3V. So I can actually do 2 times U, which is 3I plus J, minus 3 times V, which is 2J. Then I can distribute. I'd get 6I plus 2J minus 6J, and I get 6I minus 4J. I'd get the same answer by taking it out of component or taking it out of IJ form, putting it in a component form, but then at the end I have to put it back anyways. When you do IJ, you shouldn't have brackets. If you do component form, you have to have the brackets. Yeah. All right, let's graph them. So what's going to be the terminal point for A? What's the terminal point for A? Where do you stop? What's the component form of 3I, 3J? 3, 3. So I'm going to 3. I'm going up to 3. I'm stopping. That's A. Go to B. What's your terminal point for B? 3, negative 1. So starting here, going 3, negative 1. And C, what's the terminal point? 6, negative 4. So I go to the right 6, and I go to negative 4. Questions on that one? All right, last thing we're going to talk about is a vector in the same direction. So it says for any non-zero vector v, the vector u over the magnitude of u is the unit vector that has the same direction as v. So a couple of important things here is the word unit means it has a magnitude of 1 or length of 1. So it is only 1 unit long. Same direction means it's going to have the same slope or same change in x and change in y. And the way we find it is this is the component form of v. So it will be the change in x, comma, change in y, over the magnitude of v, which would be the square root of a squared plus b squared. And then we split and simplify that. So this answer is a unit vector in the same direction, which means it's going to have a magnitude of 1 if we wanted to check it, but also it should be in component form. So the answers here is literally going to be in component form. An example would look like this. Find the unit vector in the same direction as the given vector and verify the result has a magnitude of 1. So I go to A. I'm doing u over the magnitude of u. U is 1, negative 3, so that's my numerator. The magnitude of u is the square root of 1 squared plus negative 3 squared. Square root of 1 plus 9, square root 10. Now we need this to be in component form, so we're going to split this. This is 1 over root 10 and negative 3 over root 10. Can I leave it that way? No. I simplify it by rationalizing it. So I get square root 10 over 10 and negative 3 square root 10 over 10. This is the component form of a unit vector in the same direction as you. Now the second part of these directions said verify the result has a magnitude of 1. So to verify, I would go back before I rationalize and find the magnitude. So square root of 1 over square root 10 squared plus negative 3 over square root 10 squared. What's the square root of 10? What's the square of the square root of 10? 10. Negative 3 squared would be 9, and then the square of the square root of 10 is 10 again. And I get square root of 10 over 10, square root of 1, which is 1. So if it says verifying, you're really just using that to check your work. You don't have to do that in order to find the unit vector in the same direction. You do B. Find the unit vector in the same direction, and that is an I and a J. So it's a negative 3I minus 4J. All right, so the vector for the component form is negative 3, negative 4. It goes over the magnitude. This is a triple, 3, 4, 5. Could have been there, so you could have done the shortcut. But that denominator should be 5, and then you just split it. You don't have to rationalize this time. If I was checking, so to verify that it would be 1, I would get the square root of negative 3/5 squared plus negative 4/5 squared. And then that's 9 over 25, 16 over 25, square root of 25 over 25. That's square root 1, which is 1. So again, you'd be using that to check. Questions on this? There is a question, I think it's on the homework too, that says a vector in the same direction with a magnitude of blank. So unit vector means it has a magnitude of 1. You would do it just like we just did it. But then if it said it has a magnitude of 3, let's say, then you do what we just did, but at the very end, you multiply it times 3. So if it didn't say unit vector, it said vector in the same direction and the magnitude is blank, then I would take what I just got here and I would multiply times 3. So I would literally distribute the 3 into both, and I get negative 9 over 5 and negative 12 over 5. So that's if it doesn't say unit vector. If it says unit vector, that means that magnitude is 1. If it says a vector in the same direction with a different magnitude, then you find the unit vector first, and then you multiply in the magnitude times whatever they give you, okay? All right, last thing, and then we're done. This one, pretty much, we've already done this. This is nothing new. Let V be a vector from initial point -2, -2 to terminal point 2, 3. Write V in terms of I and J. So you're doing this. You're finding the component form, and then you're putting it in terms of I and J. And then for real, we're done. So do this one. All right, initial point was -2, -2, terminal point 2, 3, and you're writing V in terms of I and J. So you find the component form. 2 minus a -2 becomes 4. 3 minus a -2 becomes 5. And then you want to rewrite that in that 4I plus 5J. Raise your hand if you got it right. Okay, questions? Okay, it's a lot of stuff in vectors. Obviously, that's why we're going to break it up. But today, like what we covered up to this point is what that first assignment will be. It says part 1 on web assign.